Before we begin working this through, take a moment, read through the problem, and then I would suggest that you actually then try working it out for yourself first before continuing. So pause the video, read it, do it, and then continue on, and we can do it together from there, and we can then figure out any little hitches that you ran into and how to overcome them. All right, so we know that we got this stone that's dropped into a lake. The ripple is going outward at 60 centimeters per second. And so, of course, if it's moving outward, the area's got to be getting bigger. So there's no question about whether it's getting bigger or smaller. It's just a matter of how quickly it's getting bigger. How fast is that area increasing? Now, in this case, because we are talking about area, we want to write an area equation. So area of a circle, we know that area equals pi r squared. All right, now I need to know the rate at which the area is changing. That means find the derivative with respect to time. So find the derivative with respect to time. And then we get this, and you'll notice that the pi is just a constant, remember, so that constant continues just hanging out front in our derivative. All right, next up, I can go ahead and start plugging in information I know. Now I want to know what d over dt actually equals, so I definitely am not going to be able to plug anything in for it at the start. But I can go ahead and plug in for my r over here because I know that the radius is presently 300 centimeters. Now, if you're sitting there saying, wait, where did 300 come from? We weren't told it explicitly in the problem, but what we were told is that it's traveling outward at a speed of 60 centimeters per second, and that it's been doing so for 5 seconds. So 60 times 5 tells me that the current radius must be 300 centimeters. All right, and then it's going to be the dr over dt, the rate at which the radius is changing, and that's our 60. All right, now that I know that, it's just a matter of doing the math. And if I leave it all in terms of pi, I end up getting 36,000 pi square centimeters per second. Or if you went ahead and multiplied that out, you'd end up getting 113,097 square centimeters per second. That's rounded to the nearest whole. And if these seem like big numbers, that's because they are. By the time we've gotten out to a radius of 300 centimeters, we're encompassing a much bigger circle. And the more that I add out, more distance, more radius there, the more it is encompassing. And so that radius keeps getting bigger and bigger, even faster and faster as we keep going out.